My name is Stephen Bashong. I'm the associate editor of Solar Power World magazine. This is Solar Speaks Live, powered by Unirac. Today I'm here with Bill Brooks. He's the principal of Brooks Engineering. Thank you for being here today, Bill.
Thanks for having me.
Absolutely. So maybe we could begin just by talking about what Brooks Engineering does for the solar industry.
Well, I've been working in the industry for about 27, 28 years now, and in grid-connected PV, which not a lot of people can say, and been really working on what I would call implementation issues. It's the kind of where the rubber meets the road, codes that dictate how things get installed, the standards that dictates how products are made, working with the people that have to build the systems, the installers, training them, helping them understand issues that need to be dealt with, working with code enforcement people that have to figure out what the code actually says and how to enforce it properly. So that's kind of been my career. Do a lot of consulting, on products for code compliance. So training, code compliance, and codes and standards work, which is, I guess, not what you would say the most exciting thing to do in the world, but it's one of those necessary things. So that's really been why I do it.
Well, to put it simply, you're involved in many aspects of the industry. So I want to ask you a couple high-level questions to get this started with. First of all, the world of code and standards is really a balance between reliability, cost, and safety.
Yeah.
And all of those interests set us up for conflict. How should people manage conflict?
Yeah. Well, it's a huge challenge. I mean, from day one, we could say that the solar industry probably was better at putting together codes and standards than most industries. They were very, very much ahead of the game. And the first electrical code article went in 1984, way before there was really any solar business, PV business at least. And so, we've kind of been ahead of the game, done a pretty good job of staying ahead of the game. Where it's become interesting lately is that now the money is so big and there's so much going on, it's such a big industry that everything that happens affects a lot of dollars. And so safety...
What's an example? What do you mean everything that happens?
If you had to add a safety to something that wasn't required before, it becomes an adder in cost.
Okay.
And that adder in cost, if it's a 0.5% adder in cost, which would be a fairly big adder. That now is, we're talking about millions and could even be billions of dollars, quite frankly. So understandably, a lot of people get involved and a lot of people get concerned. And so as we become popular in the world and we're being successful, the awesome thing about this is that solar is successful. When I started in the 1980s, it was actually a bad word to say solar. Solar had gotten a really bad rap in the solar thermal industry, and so we're now in a place where it's cool. Solar is cool again. That's awesome. But
Vice President is here today.
The Vice President's here today. I mean, the President has, put it in his speeches, and those are things that never ever happened before. In the 80s, it was like, Ronald Reagan taking the solar system off the White House. That was the big news. So anyway, and today, it's always a challenge to say, okay, we're living in an environment where a lot of people are watching us.
Right.
And so we have to include them. We have the roofing industry, we have to include them. We have the fire service, we have to include them. We have the insurance industry, we have to include them. We have the financial industry, we have to include. So you have all these different parties that come to the table, and they all come from a little different viewpoint.
Yeah.
And that viewpoint is not how much solar can I put in. It might be something different than that.
Right.
So we have to balance those safeties, and that's a real big challenge. And it takes, I think, people that have been in the industry for decades to help guide that, along with really smart people that are new to the industry to help, balance those things out and figure out what's the right step forward.
People here at Solar Power International are going to hear a lot about the ITC. I'm sure they already have. What's your take on the ITC? Whether it will be extended, if it needs to be, things of that nature.
Well, and as we were talking about, as we started, my view is a little bit different than most, and it comes from the experience of many, many incentive programs. And the ITC is just one of many incentive programs, and it happens to be a federal one. That's a really, really important one to our industry. There's no question about it. It's been a foundational one. It was around when I started. In 1988, it was, the ITC was there. There was a 10% ITC there. And so it got boosted, and that was great.
When did it get boosted?
It was in the mid 2000s, 2000.
Okay.
I don't know. I lose track of time, but it was in the mid 2000s, 2005, something like that.
I'm curious why it was boosted from 10 to 30.
There was a lot of great political support.
Okay.
You know, and so what we're seeing today is in part because of a lot of great political support and a lot of great work in the federal government to support the use of solar, and so there's no one piece or part that you know is the reason so many people are here today, but that's certainly one of those. Right. Okay. And so when we have an incentive program, these incentive programs are intended to kick things off and get things moving, and it did. Here we are. We're doing amazingly well. And then there's typically, the ones that have been successful have been the ones that have phased out over time.
Okay.
So whenever you have a step change in an incentive program, anywhere in the world this has happened, it has major implications to the business world that are working with these things. Financial world, everything takes a huge hit. Right. And all the companies that are involved. So California went through a bunch of what I would call roller coasters, or some people call it the solar coaster, right? And so they had great incentives, and then the incentives went away, and then they were great incentives, and then they went away, and then they ran out of money, and then they found money, and businesses were just going crazy over that, and that wasn't a good thing. So finally, after about the third or fourth roller coaster ride, people said, listen guys, just give us some certainty. You know, I'd rather have a smaller incentive with a little more uncertainty than no certainty, and you know everybody jumps in and then everybody jumps out. It kills me. Right. So that's what I would like to see in this ITC discussion. What I heard earlier this week is that the first ask is to extend it for 5 years. Right. Well, that's all that's doing is extending the cliff. Okay, 5 years is going to come fairly quickly in this world. All right, so we extend the cliff, and now we have a new cliff we have to worry about that's going to have an equal impact, and it's going to have a lot of problems with it.
So what would you suggest?
So the best way to do this is early on get people to agree to a good visibility on a phase-out program. Okay. What the numbers are, you know, we could play with those, but I think if you showed, and these proposals have been thrown around, a 5% decrease over time, 5% a year, phase it out over 5 years. 6 years, it would be with a 30% credit. Well, actually, if you phase down to 10%, it would only be, 4 years? So do a phase down program is what I would call it. It gives visibility to financial industry. They see what's happening. People can adjust on an annual basis, and we can get to a point where it doesn't have this massive impact. See, because I believe that regardless of whether the ITC passes, the extension passes, or it doesn't pass, there's going to still be a negative effect next year. Why? Because there's not going to be enough visibility as to whether or not it's going to pass in time. The big projects are already going to have to push their dates up into 2016 regardless. Prices are going to go up. The taxpayer's not going to get as much PV for their money. And at the end of that, we're still going to have a huge lull in the early half of 2017 because all the projects have been moved into 2016. So we'll still lose a lot of companies in the first half of 2017, even though the ITC is still there.
Like you said, you've seen a lot of incentive programs globally. What's your feeling? Do you think we're going to get an extension?
I think it's a really good possibility. Okay. Okay. If it was a 70-30 probability that we're going to get an extension, is that good enough? I don't think it's good enough because I think for the financial world, they don't like that. That's still you tell them 99%, they still might get a little bit, wheezy over that. So that's why I say if you can guarantee visibility into the future, that tells the financial industries and all that. But unfortunately, governments have not been good at that. We can go around the world, look at Germany, look at Italy, look at Spain, and look at California in the past, where they just haven't done that. And the only one that I can really say has been super successful has been California after their third failure. And so why can't we learn from that? And the answer is, well, and some of this is just how you play the game. It's like, well, we're going to play our cards this way. We're going to throw our cards down on the table and we're going to say, give us everything for 5 years and see what happens. And then we'll fall back to a scale out, a visibility position. Right. And it's like, well, the visibility position is the better play because you're still not giving anybody any certainty when you're playing your cards, all or nothing cards. So,
well, why the government can't help us more than they are is a whole nother conversation.
It is. We've got other things to talk about.
Yeah, we do. Like one of your consulting specialties, which is training.
Sure.
So I was curious if you've seen any trends or what the training issue of the day is. Are there any gap in knowledge or skill sets that you've seen that need to be addressed?
Sure. I think my claim to fame growing up in this whole process has been troubleshooting, and so I get a lot of calls on troubleshooting, and usually when I get the call, it's because 5 other people tried and they couldn't figure it out, and so I get fun ones because the easy ones, the phone doesn't ring for the easy ones, but the reality is there are some of these calls that I get after the 4th or 5th person's been through it, and it really wasn't that difficult. And so I think that there's the skill set of troubleshooting is one of those gifts maybe, but also it requires training for people to understand some of the basics of how to troubleshoot, how to understand what's going on. So that's part of it. And now we're into asset management. That's kind of the watchword, O&M, asset management. That's been an issue from day one,
right,
but it's only become cool to talk about in the last couple of years. And now it's a big deal, We've been trying to do, I wrote my first O&M manual in 2004, So, they've been around for a while, but now we're getting to the point where people see the value of it. They see that it's important. You actually have to make these things work. In the early days, the incentives were so obscenely large that it didn't even matter whether the thing worked. Now, obviously, the performance is a big deal, and
right,
it has to work. There's no two ways about it. The economics are absolutely predicated on performance. So now it's all about how do you get these things to work? How do you get people that are knowledgeable enough to keep them working? And what are the things you put in place? So that's one of them.
What is your advice on that topic? How you get people knowledgeable enough to keep them working? How do you go about hiring that workforce?
That's a challenge because, like I said, our focus has all been about installation, right? So it's like, how do we install it? And certainly installation is a major part of the battle. You got to get it installed properly first. But now that it's in there, what are the tools that people have to have in the field? And so now you see some big companies out there that are doing asset management, and they are essentially having to build their own workforce because
right,
these are things that they can't go out and find people. They essentially have to build it from inside.
Wow.
And so it is a challenge. It's an area that has it. So there's been there was some training here at SPI about O&M and things like that, and those are really helpful. And some things might depend on the style of the plant. Certain things have to be taught for those folks, and other issues are not important. So that's just one area.
Right.
There's obviously design issues and things like that, and we still have a huge gap of understanding. Yesterday, I flew back to Northern California to teach the California building officials. Well, that's a huge gap in knowledge. There's so many people in that world, and they have to know something about this, and they're being charged with approving PV systems.
Absolutely.
So if they don't know what they're looking at, and then you have people that are screwballs that are trying to, basically make a quick buck and cut corners, what's that going to do to the solar industry? So the solar industry needs to have a knowledgeable inspection and code enforcement force out there so that they can keep people running on the straight and narrow on how to do things right.
Is there something like that evolving?
Yeah, I think so. I think the federal government has done training in this area. I think it's beginning to become more obvious to them that they need to do more training. I think they're going to be doing some announcements today about some training efforts and all, and they've teamed up with other organizations that do training. But there's always going to be a big need for training in that area.
You mentioned design just now.
Yeah.
What is your feeling on current residential and commercial solar array design? It seems robust to me, but I'm not out there a whole lot. What aspects of solar design need more work?
Sure. That's a great question. They're always looking to improve, always looking to make things better, cheaper, faster. I mean, you look at things like, give an example, ZEP Solar, that changed the world, and then, so innovation. You want to certainly make sure that, and this goes back to the codes and standards world, that you have a platform where innovation can thrive within the bounds of safety. And so good ideas are also, I believe, safe and reliability ideas too. And so the ideas that are going to win are the ones that really have the synergies that pull it all together.
That approve systems across the board, safety, reliability,
That's right.
and cost.
Yep. I mean, a good example of that, you know, we're sitting here in the Unirac booth and all this kind of stuff, and so all the work that's gone into bonding a bunch of metal parts together, it seems like a really simple thing, but there's been more angst over that issue in the installed world than almost any other issue, and it seems kind of silly, but we're now in a position where we've got standards that can support that whole process, make it way easier for the installer to put it together, and way cheaper. I mean, the amount of labor that has gone into running copper wires all over aluminum racks has been absolutely ridiculous. And so now we're getting away from that and we're reaping the cost benefits of that. Plus the fact is that you know, the installer's not going to make a mistake because it's easy for them to put it together the right way, fast. All these things are all about innovation.
Innovation. What's the most exciting, speaking of innovation, what's the most exciting development you've seen in project design lately?
Well, I think that certainly, you know, we mentioned ZEP, those kinds of ideas, but we're seeing a lot going on in the electronics world, and that's a very controversial area as well. You know, there's
specifically, what do you mean in the electronics world?
So where we're starting to embed electronics at the module level and around the array and in the array, kind of integrating electronics to the array. Historically, all the electronics has been in the inverter. And we just keep adding and adding and adding electronics to this box, and that box just does a million things now, and it talks to you and all this kind of stuff. But there's really value in looking at, okay, what if we take some of these electronics and start to move them into the array? And we can move any portion of that electronics all the way up to, of course, microinverters that moves essentially all the electronics into the array. And so there's a continuum of different ideas where certain amounts of those electronics make sense in that array and improve performance, could improve reliability, and that's the real big deal there. When we talk about moving electronics in the array, everybody can and should get nervous because it's a really tough environment. It's a tough environment for a module to last 20 years, much less a piece of electronics to last 20 years in that environment. So it takes a lot of engineering, it takes a lot of testing, it takes a lot of effort to make something that is going to last the test of time. Essentially, the test of time is you want it to last as long as the module is going to last, and that's a really, really tall order. So when we get into the codes and standards world, we're saying, okay, right now the electrical code is talking about being able to shut off PV modules in an array as one of the options for safety, and it's like, wow, that means there's going to be some electronics in that array, and what does that mean for the solar industry? Well, what it means is that we better get our act together because that's not an easy thing to do. I mean, there's a few products on the market that do it today, and they're pretty good at it. But what about another 20 companies that come into the market? Are they going to be as good as the ones we have today? And the answer is, I couldn't tell you that, and I'd say that in the early days, it's probably the answer is going to be no, they're not going to be as good, and there's going to be reliability issues and problems, and everybody's pointing to that right now. But when we come out the other side of that, there's so many things that we can do by looking at the value stream from the module and the array all the way down to the inverter, that we're going to learn how to do things in the best possible way for the residential market, for the commercial market, and eventually, and also for the very large scale market.
I mean, you've been in the solar industry, since the 80s?
Yep.
What's the most surprising thing about the way the solar industry has evolved over the last, 30 years?
Well, back in the 80s, the small group of people that would have probably fit in this little booth here, we would sit around and chat and talk about, how cool PV was and what an unbelievable technology it was, and we believed in it. I mean, we were sold. We were like lock, stock, and barrel. This thing is unbelievable. And we knew that it had the possibility of being something great.
Okay.
But it was really stinking expensive at the time, and we didn't really know how that was going to get a whole lot cheaper. And so we talk about how one day every house might have solar on it, or a whole bunch of houses, millions of houses would have solar on it. We actually never believed any of that. We just, we just talked ourselves into it. We dreamed about it. We dreamed about it. And we also dreamed about it and said, well, if that's going to happen, what do we have to do today? because
Okay.
that's maybe a decade or two away, and it was. And so I think we did a lot of planning early on that helped. It was an enabler. Did it make this happen? No. It was just a major piece of the puzzle that had to be there as things went forward. You know, and the utility interconnection market was a huge part of my early career. Was how do you even get the utility to allow this stuff? Because in the early days, as you might expect, and even today, the utility, there were some in the utility industry that maybe weren't so happy about having solar come into their backyard. So those are issues. But the idea that it might happen and it might, you know, the biggest surprise is that it actually did.
Yeah.
You know, you're standing around going, this is a little bit surreal for people that have been around for a couple of decades. It's like, and I like chatting with people that have been around for a couple of decades because we all look at each other the same way going,
wow, I can't believe it.
Yeah,
Did you envision like a solar city putting arrays on roofs in 17 states and utilities building their own, you know, giant solar arrays?
You know, the funny thing is, I actually did, you know?
Okay.
Because one of the things that I saw early on is that the solar industry, specifically in the residential market, was very much like the HVAC industry. You had the mom and pops that put in air conditioners for you and stuff like that, and then you had the carriers, the trains, and you had these guys that just put in subdivisions and just crank the stuff out. You know, big, massive organizations with master trainer programs and all this kind of stuff. And I said, you know, that looks like to me what the residential future. We need to have organizations out there that are super organized. They're grease wheels. You know, I love mom and pop organizations, and they will always survive because they're going to be doing the niche projects out there, just like they do for the air conditioning industry. But if you want the lowest possible cost for an air conditioning system, you're going to go after a company that's got 1,000 employees, that has trucks all over the place. They put these things in 2 hours, they're out of there, you know, whatever it is.
Yeah.
And they've worked all the efficiencies that are possible. And the mom and pop organization just doesn't have that option.
What's your example of a niche project for the mom and pops?
Well, a niche project right now could be a battery storage project, you know? It's like, there's some products out there and it's coming along, but you know, even the Powerwall from Tesla isn't on the market yet. So if you want to do a Powerwall today, you don't do a Powerwall, you do something that kind of looks like it. And it's got to be kind of kludgely put together.
Yeah.
And so that's a niche market. Or, you know, for whatever reason, the programs that are out there, the financing programs that are out there don't meet the needs of a particular customer because they're not going to meet all the needs of every customer. Right. So the mom and pop said, hey, we'll come along, we'll sell you a system direct, you know, you can buy it and you can take the tax credit and all that kind of stuff, whatever it is. And so there's always the niche markets there, and then there's going to be something about the way that they want that system that's different than what anybody else provides.
Right.
And so, yeah, they'll always be there.
Well, Bill, I've taken a lot of your time today, but I want to ask you, you've seen a lot of solar projects. Which was your favorite?
Yeah, I was thinking about that before we got together, and that's a really tough one because, you know, you have to think about, well, this one, you know, was my first. You know, it's kind of like you always have your first, you know. And so that one's got to have a lot of special, you know.
Yeah.
I did the solar house at North Carolina State University. There's got to be a special place for the first. And then my first commercial system where we built an awning on the side of a building, that was really awesome, you know.
Okay.
And that was the first 3-phase system in the state of North Carolina. And, you know, and it was cool looking. Everybody liked it. You know, it wasn't ugly. So that was the kind of the thing. We put you know, valence around it. Nobody knew it was solar. You know, it was cool looking. You know, and then I would say, you know, I did a project in the mid 2000s with a couple of buddies in Hawaii at the National Energy Center. And it was unbelievably difficult, but it was a beautiful space frame structure, and we had to climb around in it with harnesses on, and just really hard to install. But you know, when we were done, it was this gorgeous masterpiece of a sculpture. You know,
it's really cool.
So you know, those are the things that kind of stick out in my mind.
So you have a lot of favorites.
Yeah,
that's okay. All right. Well, Bill Brooks from Brooks Engineering, thank you so much for being here today.
Enjoyed it. Thanks for having me.
Awesome. My name is Stephen Bushong. I'm Associate Editor at Solar Power World. This has been Solar Speaks Live, powered by Unirac. Thank you.